I asked ChatGPT, give me a definition of artificial intelligence for sixth graders. And it came up with, I thought, a pretty good explanation. It's machines that learn and make decisions like humans. Okay, that's what AI is for most of what we want to deal with. Okay, it's machines, typically computers or software that learn and make decisions like a human. And it's like a human that's really important. Okay. So thank you to PowerPoint for suggesting my little animated brain there that comes up with stock video from PowerPoint. It's all part of doing everything with AI that you can to try and minimize the work you really have to do yourself these days. AI is made up of software and hardware. Okay, so it requires software in the form of computer programs that are written by AI programmers and AI application developers, and it requires hardware because software by itself won't do anything. It's like taking a pot of water and you want to boil it and you don't have a stove or a microwave to put it in. They have to go together. Okay, so you need the hardware and the software. So understanding the software of AI and the hardware that makes AI is what really helps make it understandable. Software is made up of algorithms. Algorithms are mathematical formulas that are used to come up with decisions in software. And they can be simple formulas like addition or subtraction, or they can be complex formulas like linear regressions. AI uses a lot of mathematical formulas that get more advanced than just simple formulas that we might know how to use every day. And it's the algorithm, the actual formula that makes AI work. It's worked out in software, and that algorithm can be one or many different algorithms. Okay, it's not just one algorithm, it's many, many different mathematical formulas that have been developed over time that have come closer and closer to helping make a computer, meaning a computer combination of software and hardware, come up with the ability to learn things and behave more like a human being. So as we get better and better at understanding the mathematical formulas that can make this work, improvements are made by people that develop artificial intelligence programs in refining these programs to make them more and more efficient, more and more effective, more and more accurate, and more human-like in terms of their behavior. So algorithms are at the foundation, every software, but there are more advanced algorithms that are used in AI than we might use in another type of software program. There are a lot of computers that are used for AI. It requires a lot of physical computers, physical chips that do things. But a lot of the computers are made up of what are called parallel processors. Okay. And parallel processing means solving more than one algorithm at a time. Okay, so when you can do more than one thing at a time, you can get things done faster. So if you had a road that was one lane in one direction, only one vehicle at a time can go in that direction. But if you build a two-lane road, two cars can go in that direction. If you build a three-lane road, three cars. So parallel processing gives you the ability in computing to make more things happen at one time. Numbers and information are manipulated in what's commonly called a matrix, which means there are relationships that are defined by linking things together in many, many forms and connections. So it's not just a sequence of activity that takes place. It is called a matrix because there's more complex types of connections between things. Think of it as a cube where different things are connected to each other in a variety of fashions. And then the computers that calculate and are used for AI are designed to be more efficient at AI than what you might see as a general purpose computer, like a computer in your computer or your phone or your car or other things like that. And so these types of things make it easy to do things really, really fast. And by doing things faster, instead of doing one calculation at a time, you can do a lot of calculations at one time. And that's the parallel processing that the companies that make the computers that do AI are valued for, is they design these computer chips so that they are designed to be able to handle a lot of calculations at once. A lot of these are referred to as what are called neural processing units because they can process things not just in sequence, they can process things through simultaneous relationships, more like a human brain calculates things. So a human brain is made up of neurons, and pulses pass through neurons and activate other neurons. But as they go through neurons, something happens, something changes, something is added, something's deleted, something subtracted. And so no one neuron necessarily makes a single decision by itself. It's the combination of all of these neurons or chips, or processing units that take place that actually begin to act and more like a human brain, that just don't go from one step to another. They calculate things in the middle and then come out with a result at the end as a result of analyzing all the relationships that take place between all of these pieces of information. NVIDIA is a really big maker of a neural processing unit. They're extremely valuable as a company. They're used a lot in virtually every AI facility around the world. They make a specialized processor called Tesla. And NVIDIA kind of got into it because it turns out that NVIDIA made what are called graphic processing units, which are designed for displaying computer graphics on screens. And it turns out that the same capabilities that allowed that type of processor to display graphics did parallel processing, analyzed matrices, was very, very suitable towards doing the calculations that are required for artificial intelligence. Google makes its own processor called the Tensor Processing Unit. Apple has a neural engine. Amazon has one called Inferentia. So they're all slightly different designs, but they are all designed specifically to do the types of calculations, the type of algorithms that make up artificial intelligence, as opposed to an algorithm that might tell you how long your microwave should go or when your dryer is dry, which are computers that do it, but they're much simpler algorithms and much simpler software programs. Now, another term you might hear is something called edge computing. With Google's new Gemini model, one of the things that they feature about it is the fact that it comes in three sizes. It comes in a data center size where you've got to access it through an internet connection and it runs in their data center, but they also make it so it'll run smaller, meaning when it runs smaller, it will run closer to you, like in your cell phone or on your tablet or on your computer or on some other special purpose device like a vehicle, an autonomous car, or an X-ray machine or something like that. So edge computing refers to putting the processing, the work of doing everything close to where it needs to be done, as opposed to in a data center somewhere where you have to get over it through the internet. We were talking a little bit earlier about how Google Translate as an application gives you the ability to download languages and use Google Translate on your smartphone, as opposed to having to go out to the web all the time. So that's an example of edge computing, where we're putting the work closer to us and not using that centralized cloud computing environment. So we're going to see a lot more of that in different types of AI models. Okay, you hear this term called AI models. It basically breaks down to two things. It's an algorithm that learns, and it has a way of learning. So combining the algorithm that learns with the way it learns is what is commonly referred to as an AI model. So you hear ChatGPT, that's an AI model. You hear a Bard or Gemini, that's an AI model. It's a software AI solution that learns and behaves in a particular way. So that's what makes it an AI model. Instead of calling it an AI app, it's called an AI model because it has this ability to learn. Applications don't usually have the ability to learn. If we think of Microsoft Word or Gmail or other types of applications, they don't necessarily learn and do things on their own that as we use them or as they learn from their own. So AI models are applications that learn, and they have different ways of learning too. Just like people have different ways of learning, AI has different ways of learning too. And as time has developed, people have developed different ways of helping AI learn. One of the things that AI needs in order to learn, it needs lots and lots of information. If you're trying to get something that recognizes a photo of a dog versus a cat, you have to teach the AI how to do that. And one of the ways to do it is to show it lots and lots of pictures of dogs and lots of pictures of cats, and then help it understand. So you need a lot of data. So you might hear this term data mining, which is the ability of discovering patterns in lots and lots of data. And that's one of the things that these algorithms do is they just don't scan it. We had microfiche machines that would scan data, but AI helps discover patterns in large data sets, which is one way things like facial recognition is done. It discovers patterns in hundreds of thousands, if not millions, of pictures of people, of objects, of text, of other types of images. It discovers patterns. We have the ability to discover patterns too. We know, like, when traffic is busy. We know when grocery stores have get stuff in stock. So we discover patterns, and AI discovers these patterns as well, and it has the ability to do that. That's one of the things that the algorithm has been enabled to do, is it has the ability to discover patterns, and then it can start to learn from them. So once you have all the data, then the AI algorithm can start to learn. One form of learning is machine learning. Machines can learn from the data. Okay, so when they learn from the data, they are able to start to form relationships and discover patterns and make decisions about things that they're discovering in the data. Like, why does a green donut have yellow sprinkles on it? What's the difference between a chocolate and a cake and a carrot cake and other things like that? So they can start to discover what is called machine learning. And there's a couple of ways to do machine learning. One way is to do it supervised. Okay, algorithms can learn from what is called labeled data. A labeled piece of data is something that has been identified as a particular kind of data. This is the color green. This is the color yellow. This is a rectangle. This is a square. This is a slope. This is a triangle. So labeling those things and telling the software this is a label. So as you start to say this is a triangle, and you show the software many, many different types of triangles, it can figure out as it learns, oh, okay, anything with three sides is a triangle. The angle doesn't matter. The angle just makes it a different type of triangle, but it was told that it was a triangle to begin with. Just like it might have been told it's a person or an eye or a color. That's called labeling. And we label things all the time. So, and that helps us learn. when we see labels. You think of road signs as a label. You know, we recognize a stop sign, we recognize a caution sign, we know a green light. You know, we had to learn these things. Somebody had to tell us these things. So supervised means it's been helped. There's unsupervised, which means the algorithm can start to learn from the data by finding patterns of its own. This is where some of the AI starts to get really creative, because it might just take a look at a bunch of images or a bunch of pictures or a bunch of text, and it can figure out the patterns on its own without having to have labels assigned to it. Sometimes it helps to have an AI do supervised learning to start with, and then it can go unsupervised after it learns more. But if you've used a chat GPT or other types of tools, sometimes it will ask you for feedback. And that feedback is the ability for somebody to label a piece of data, but sometimes it can learn and find patterns on its own without having to be supervised. Just like a person or a child, sometimes kids need to be supervised. Sometimes they can learn without being supervised through trial and error, and they learn how to do things, right? So these algorithms are behaving more and more like people behave to learn things, which is what is making AI so much more powerful. And then another one is a form of reinforcement. They try things out and they get feedback, you know, from their own actions. You think of it like training like Pavlov, you know, or something like that, where you reward it when it does something right and it learns something and does something right, gets feedback from user response, from information, from other AIs even as well, because there's another type of AI learning style that uses more than one AI to help learn. So these are not all of the learning styles. These are just some of them. And as you can see, they are learning things the way lots of times people learn things. And that's what's the power of AI, is the algorithms, the learning formulas that are helping them learn are more and more human-like in their behavior. And then there's this other one called deep learning. Okay. Deep learning uses something called neural networks with many layers to learn large amounts of data. And one of the best ways I thought to communicate this with some help from ChatGPT was, imagine an office with 1,000 cubicles. And the first person in the first row in the first cubicle nearest to you has one job. Their job is to identify a picture and identify what's green and what's black. The next person in the next cubicle has the job of identifying what's blue and what's white. And so every person in that row has a job to do to make a decision about learning something about whatever picture is being shown. No one looks at it and says, oh, this is a mountain or a lake. They say, no, this is green, this is blue, and that's all they decide. Now, once the first row is done making all of their decisions and learning about the picture, they pass it on to the row behind them. That's called a layer. When it's passed from one row to another row, to another row, to another row, and to another row. And each of these decisions is being done by what is commonly called a neuron. So if you think of that cubicle as like a neuron, it's making some decisions and it's helping to say, well, this kind of looks green or it kind of looks blue. Maybe it's kind of in between and it can't make a decision. Well, it passes it on to the next layer behind it, and that layer can make a decision. And so you've got these layers that go on. So every time something is happening in an AI, it's not just happening with one point of information or one processor. It's happening with many, many processors in many, many layers. These are, AI tools have dozens and dozens and dozens and even hundreds of layers, and they're all doing something all at once. So when ChatGPT or Gemini has to come up with a response to your question, every word is going through all of these layers of decisions in order for it to come up with a decision, which is why the calculating and computer requirement is so demanding right now, is it just takes a lot of decisions that coordinate with each other and evaluate whether this is the right word. Is this the right word? Is this the right color? Is that the right color? Is this the right shape? Is that the right shape? Is this the right translation of that word? Or is this the right translation based on the context and what came before it, what's going to come after it? So these are layers that take place, and it actually comes very similar to how our brain works, is that we just don't let one neuron make a decision in our brain. We have many neurons that come up with the ability to make decisions when we are learning. And so this is why AI kind of resembles how humans think. And when it's working, it works really well. You get all these people in all these cubicles, all these, nodes in a network, all these layers that are just making decision after decision after decision for us. So a neural network it's a set of algorithms that recognizes patterns. It's interpreting data through machine perception, like sensors. We've got touch sensors, we've got volume, we've got labeling or clusters of raw input. So they interpret the data and they are able to do something like recognize a voice and create a translation. So they can recognize something and translate. So it's not just one single piece of data that's happening when it hears a word. It's a lot of pieces of data. It's a lot of decisions that are taking place. It's a lot of algorithms that might be factored into taking that place. And all of that together creates what is commonly referred to as a neural network. And that's what gives us the ability to do things like voice recognition or generating text or other type generating images, is this neural network capability. Now, another part of AI is called natural language processing. It's a type of algorithm that enables machines to understand and interpret human language. Not all AI is interpreting language. Some AI is just trying to tell, one color from another, or to tell a car to stop when it sees a pedestrian coming in front of it, or to tell, somebody that they need to be reminded to do something. So natural language processing is a set of algorithms that deal specifically with human language. And we use language to communicate. It's part of who we are. So it gives the ability for a machine to understand and interpret human language. It's another set of algorithms, software tools, mathematical formulas that have been created. One last type of learning tool is called a transformer, and it's an AI that learns from words to understand and respond to words. It's specifically designed to learn about words. So it uses neural networks, it uses other types of algorithms, and it's specifically designed to learn and understand words. That's why it's called a transformer, as opposed to another type of AI that might be used. So all of these things come together, and there's another type too. There's something called a generative adversarial network. Sounds more difficult than it is, but when certain animal species fight for dominance, right? You can think of a general adversarial network as a little bit like that, but not exactly. Basically, a generative adversarial network is a learning method where two AIs learn to do something together. One AI, first of all, what happens is the data is given to both. So they all have the same data. Both AIs have the same data. Both AI have done all the deep, the data mining. They have everything that's together. So they both have the same information. One AI creates data that looks like the input that was created. So if one AI says up, another one says kind of up or whatever. And the second AI learns to tell the difference between the AI created data and the real input, and starts to learn by comparing what essentially is a similar but not real piece of data and the real piece of data. And by learning to tell the difference between yes, maybe, and no, it can learn the differences between them. And so it's a way to train an AI. Again, there are lots of ways to train AIs. And once they are trained, they are a fully functional model, but they can learn and they can continue to learn on their own. So there's lots of different ways to learn with AIs, just like there's lots of different ways to learn with people. And that's one of the things that has really changed a lot about AI, is this ability to find different ways to teach them where they have gotten faster and better and more capable at a faster rate than what we might have thought possible before, along with this type of computing capability that's been developed where you can run a lot of these types of learning processes simultaneously and make them happen really fast. Generative adversarial networks are commonly used for image generation in AI. Makes sense, because if you're trying to create a fake, elk versus a real elk, it'd be a good way for an AI to learn what's the real one versus the one that is missing, elements that doesn't make it an elk, or what makes it a dog or a cat, or the color green versus the color blue. So it's a contrasting capability is really good for image generation training. Now, you heard about GPT. The GPT in ChatGPT comes from the combination of generative, pre-trained, and transformer. So when we use ChatGPT, we're using a generative, pre-trained transformer type of AI. That's how it got its name. And most of the time when we're using Gemini or Bard or others, we're using a generative pre-trained transformer when we are using AI. ChatGPT, Copilot, Gemini, which is replacing Bard, are all generative pre-trained transformers. They've been trained with a variety of labeled and supervised and unsupervised and competitive techniques. They generate something, but their specialty has been that they've been trained on language a lot. They understand language and how language is used by people. The generative has to do with taking an input, which is commonly called a prompt. When we type something, when we say something, or when we show it something, we are giving it an input. We are giving our AI an input. We're just giving it some input, and we want it to do something with it. It could be text, voice, vision, and it creates a response. The Gemini announcement that Google just made is significant because a lot of AIs just do text, or they just do voice, or they just do vision, and they don't have all of these forms of input integrated together. Gemini has taken an integrative approach when they have looked at how they're going to take input and how they're going to deal with it. So there's not a lot of difference between text and voice and vision in Gemini in terms of how it handles the AI, how it handles making decisions, how it handles data, which is one of the things that's making it very promising for Google. The response can be text, images, videos, which are a little slow, but they're getting there, music, and speech. So we give AI a prompt, and we want it to do something with all the algorithms and the processing, and we want something back from it. What we get back is the response. The pre-trained means it's used one or more of these learning methods. And there, like I said, there's a lot of learning methods. Just like you can have a curriculum in an elementary school or a college, you can have practical exercises, you can have demonstrations, you can have presentations, you can have reading material, you can have watching, video, you can have shadowing where somebody learns from a mentor. All of these are training methods where we use them to train people how to do things, and we use a variety of methods to teach an AI how to do things as well. So it's been pre-trained using one or more of these methods. And again, it's a transformer type of AI that has learned from words how to understand and respond to things. So all of this gives us a lot of different usability with AI. Email spam filters use AI to detect and determine what email is spam and what email is legitimate based on not one characteristic like, who's it from, but a lot of characteristics like what's in the content, what kind of links are in the email, and it makes a lot of decisions about determining spam versus non-spam based on a variety of factors, not just one single factor. Chatbots that are used that have the ability to simulate a human or help answer questions and learn from data. If I take all of the instructions for a particular human resource policy, for example, and put it into an AI, and the AI learns all of that, and I say, okay, now answer questions for people that have questions about that information. So when they go to a human resource website and have questions about something, the chatbot can help pull from the information and respond, but it can also learn as people ask more questions. It will become smarter at learning. This is also similar to technology that's being used in fast food drive-throughs and fast food kiosks, where people are giving an order and they're getting the AI is taking the order and processing the order, but it learns to ask people, oh, okay, did you want, extra this, or did you want this way? It has the ability to do that. And sometimes it starts to do it better than a human because it doesn't forget to do things where humans sometimes will forget. So if you ever wanted to get hot sauce with your takeout tacos, and a human never asked you for that, forgot to ask you if you wanted it, an AI might not forget as readily. So there's things where chatbots are being used. Recommendation systems. Recommendation systems, and sorry about the typo there, it's just line break there. Netflix, Amazon Prime, Apple TV, they recommend shows based on your history of what you have watched. YouTube, TikTok, Instagram, Facebook, they use recommendation systems that use AI based on what they think you might want to see next and recommend that to you. Voice assistants like our Amazon one, our Apple one, our Google one are able to use and understand human voice and learn very well. If you compare what we can do now with voice assistants with what voice recognition was like 5 years, 10 years ago, it's just miraculously come up to speed much more rapidly and made it much more usable. And then computer vision, the ability to recognize an object and do things. So these are just some of the things that are being utilized. Computer vision is what's making autonomous vehicles possible in a lot of ways, but it's also being utilized to analyze radiology exams and do a first pass evaluation of things. It's being used to do things on recognize ice, on planets that are where we have rovers going and do other things like that. So AI has been being used in a lot of things. It's just getting better faster because the algorithms are learning faster on their own too. They have this learning capability. Predictive text and autocorrect are done with AI tools, and photo editing is being done with AI, where AI will remove images or enhance it or give you a better quality image. And translation tools are utilizing AI as well. So we're seeing it more and more and more, not just in text creation and image creation, but it's been coming into our lives slowly, but it is accelerating much more rapidly. And that's why we're seeing and hearing it. And this whole ability of a generative pre-trained transformer that understands language has gotten very sophisticated, but they've also discovered that this ability of a GPT type AI has enabled it to do a lot more with images and image creation that they thought previously it wasn't possible. It's accelerated that capability as well as we discover better ways to train AI. Just like if you get a dog and you learn more ways to teach your dog a new trick, you're going to be able to teach your dog a new trick faster. We're just learning how to train AIs better and faster all the time, and so they can learn and accelerate a lot more. So just in summary, these are some common AI terms. There's many, many, many more. Some of these can be really challenging to explain and understand. So I hope I've helped you learn a few and understand a few in a certain way, because AI can be so nebulous to people that understanding a little bit more about it will hopefully give you a little better comfort level in terms of what you might want to learn and deal with and move on to next and learn more. Well, thanks, everybody.